his hair's fucked up. Oh, let me get the audio going. Cool. The fuck? It's trash. Okay. It's too hot. Why is it too hot? Okay. Procrastinated too much. I was watching other shit, but it is what it is. Alright, we're here now. So let's get it. 3 hours. What were we doing last time? Last time we were talking about iterators and setting them and creating them. At least in terms of a pointer. But also, not just a pointer set to get whatever the begin is. Instead, we could actually... What did we do? We did chaining. We did, like... Well, I don't even need this. What? Iterator's not actually needed for what I'm gonna do. What the fuck am I doing? So we could do a standard array of ints. Yeah, okay. So iterators are objects that specifically handle, or objects that handle the traversal of containers. Let's find out where we were last time. Oh! Okay, so we passed through that. Alright, don't need anything else. Now we're on new shit. Standard library algorithms, okay. Are we gonna find something like quick sort? No? Okay. Oh. Here it comes. There's gonna be a lot of sort. Oh, standard sort. Okay. So I guess this assumes that normally, if parallelization isn't supported, then one CPU thread works. I don't know what we do though that only works with one. I'm not sure what code I've written that supports parallelization. Excuse me. Excuse me. It is glare. It's like this weird bit that looks like a smudge here. But it's only because of how the window's lining up, I think. Fuck. No, it's because it's from here. Inspectors to look into? The functionality of an algorithm. The algorithm is used to view the data, like getting a particular place in a complicated array, like a list that doesn't yield an index, or you can't index a list, apparently. But you could use an inspector algorithm maybe to get a certain element from the list. Okay. Changing the values. So there's like in Mage Arena, you have an array of all the characters in the world known at not at compile time but at runtime once done one time. So you could say static, and you could you could make it static if you wanted. Static change anything? Nah, it doesn't help. We could set it to by default create 8 if you had 8 players. I don't think it's helpful. Okay, I was tripping for a sec. But in Mage Arena, there are flags that you can capture, and when you capture them, they level up the spells of the entire team. So it just levels up your spell casting. So we could have mutator algorithm. I mean, or we could just, I mean, it wouldn't be hard, but whatever. So you could do like an algorithm that takes an array and then takes the value you want to add to each element. Or how you want to change each one of them. Square each one of them. Getting the minimum. Well, no, the minimum would be inspecting. Facilitators generate a result based on the values of the data members. Meaning that we pass it an array, and the point is it's using like an inspector inside it to get values of the elements in the array, but then does something specific using those values, kind of like an in parameter the function uses to do shit. It reads it and does stuff. Oh, so what do we do? Dot find and then do it, or standard find? Wouldn't we have to pass? Oh, we don't even feed it the array. That's interesting. We just do the places in memory to search. To the first element, to the last element, or rather one past the last element, so the ending element makes sense, and then what to search for. It would return a pointer I'm just going to say iterators of pointers because I haven't seen any other examples. It returns a pointer to that element that has the value you're looking for, and then you can dereference it to get that value. Or, yeah, but you could change it, you could use it. Well, that makes sense. Yeah, instead of looping through the entire array and checking, hey, is this? Nope. This? Nope. This? Nope. Doesn't match. Like, if I'm looking for 3 and I have an array from 1 to 10 and it's unsorted, I have to check. Is the first element 3? No. Is the second 3? No. Third 3? No. Finally, the fourth 3? Oh, yep, it's 3. Boom. Okay, so it's makes sense. That's our check, just like So check to validate it. Oh, hey, if found is the end of the array, oh, it wasn't found. For example, have an array, say, give me an integer to search for, because we're searching for an integer, and we have an array of integers. We search for it. Let's say, oh, a value to search for and a value to replace it with. Okay. So do 20, or we'll do 40, and we'll do 60. And okay, we'll do found. Found returns either a pointer to the end or a pointer to where it is. So we start with the beginning of that array, the end of that array, and then and then the value we're searching for. And if found is the end of the array, then it wasn't found. But if it wasn't, then we replace wherever it was found. And we can dereference it and set it equal to whatever value we want it to be. Okay. Kind of feeling music right now. Let me make sure this isn't playing in here. Ah, we're good. Yeah, so if it wasn't found, basically. Cool. Otherwise, we do it. And then we print the whole thing. Yeah, that makes sense. Find if. Oh. So what do we do? Is it a fourth one that's the condition, or how does it take? Interesting. I'll have to read that in a sec. Okay, so I'll copy something like this. Oh, I guess that's the point. You make them auto, huh? Because I don't know what begin and end and what the iterator's type is going to be. Or, no, we want it to be an int, so... Yeah, we only have auto for when we're actually getting the return value of the found, of the find. Bro, what the fuck am I doing? Bro! Alright, just chill the fuck out, dumbass. What am I doing? We could say, well, I guess we... yeah, anything else? What the fuck am I doing? Cool. The fuck? Oh, I didn't... Well... I'll do it like this. Oh, well, I guess we don't need to print it, but whatever. 38, we're gonna replace it with 10,000. Okay, it finds 38. Oh, that's index 1. Oh, replace it with 10,000. Cool. Yeah, it's fine. Okay. Huh. Be right back. My pits are a little sweaty and I don't understand why. It's just too hot, I think. Don't know why it's so hot. Okay, we're good. In the other room, the shorter switch on the light is the light, but in here, it's the longer switch because that's a great idea. Please. Okay. Oh yeah, let's do the same thing with the test the other case, right? So let's do search for 3. 100. Value not found. Cool. Find if. What does that look like? Oh yeah, I want music. Something like that. First, last. Excuse me. You would think you would search. I don't know what this pred needs to be. I was thinking like a struct that has the value you're searching for and the condition, but it can't just be the condition because then what are you searching for? Or maybe it won't know. I mean, you could have it return. I mean, if the condition is true, then it searches. I don't know. I'll be back again. Finally. Head. It's fucking Whitehead. Keep feeling it. Find an element that matches some condition. So what do I pass in? The start and end of the array, and then like part of the condition, like greater than 10, and then it would search and then return the one that's greater than 10. So we're not searching for a value, we're just searching for the condition. What are we searching for? Contains nut. Oh, and contains nut is a function that has to be called, and it passes in the value of the element. Interesting. A callable object, a function pointer, meaning just the name of it, and it will call it for each. Interesting. So we could say all right. All right, hold. And it will do the first one that satisfies it. So if we could do 11 and then we could do 23, right? And then I don't know if it's going to be end or not, but I'm hoping it's set to end if it's not found. Interesting. Yeah, it does replace it with 9. It replaces the first element. So it's not all. It's not for each one of them. We could say replace each one so we could say fuck. I could do this though. Well, no. We could do this. The point here would be saying, hey, found. The point here is that found is initialized with an iterator, a pointer to this first element in scores. So it is not this. Well, we could say we could just say do while. No, it still needs to be initialized. This is fine. And so we're going to do this at first. We're going to set found, and if we find one, so if something is found, so find value greater than 10. If not found, then no values are greater than 10. And then we could break. Excuse me. Or we could just say, we may as well just make this while true, right? Instead of calling begin every time. Okay, while true. So it's going to go forever until we break. So it'll say, hey, find the guy who's greater than 10. So it searches, it checks this element and calls greater than 10, passing this element as a value. By value. Well, or we could also do, it takes it by reference if it was expensive somehow, right? And so it calls it on here, says, oh, not greater than 10. So hold not greater than 10, but calls it on the next one. And it eventually, the find will call it on this, then this, then this, then this. Initialize found to be a pointer to element 4, so indexed with 3. So it is not initialized with end, it's instead initialized with a pointer to 11 in this case. And then we replace it to be 9. And then we go again, and it finds it here for 23 because now 11 is less than 10. Or oh, this is actually, yeah, greater than 10 was fine. Cool. And then we're going to print at the end all values replaced. Print array with all greater than 10 values as 9. Bum. So, which ones are greater than 9? 11 and 23. Now they are greater than 10. Now they're 9. And pause. Contains nut, so we say standard string view. So we get it from a standard string. Oh, okay, string views. All right. Standard string view find returns end position if it's not found. Okay. Gotcha. And so it should be true here if it's found. Is it not found? Okay, so we check if it's found. We say, oh, hey, is it initialized to be the end? Meaning that none of them were true. when called as an argument to this function? Yeah, so we could do, let's see. So we could have an array of people in the game, or, let's see, what would we do? Like at the start of a game, let's say Mage Arena, for example. Let's say that you choose whether you are a mage or a wizard in the lobby. And when you choose, or let's say everyone chooses, and then the game starts. And when the game starts, you get your skin, either to be a wizard or a wizard or a warlock. And it searches the array and checks for anybody who, when passed as a player object to this function just checks the data member to see if their data member of class or whatever is warlock or if it's wizard. And if it's this, it does this. If it's this, it does this instead. So we could say in this case, we're not checking just for one condition. We would do this twice. So we check it and check for anyone who's a wizard, and then for each one of them, give them the wizard skin. And then for the others, well, I mean, it's not really needed in this case. I mean, they have to choose one, so really, this isn't a good example. Another could be like an algorithm or something that determines whether an enemy is a threat. And what we could do is each enemy has a variable inside it, or a data member, that holds a pointer to the character that they're targeting, and no pointer otherwise. So if they don't see the character for 10 seconds, then they set it back to no pointer. So we could use this function to, for each enemy, like let's say it's your ult, and your ult highlights all enemies that are targeting you. Not all enemies. It's like a Bloodhound ult in Apex, kind of, but not quite. It's a little worse, because it's only the ones that have seen you, not everybody in the game. So actually, yeah, let's say it highlights them through walls, the ones who have seen you recently, and then you've broken line of sight of, or haven't. And so it loops through and it says, hey, there are 10 enemies on the map. And oh, this one does not have you set. It calls it with the start and end of the array, and it passes that character to it passes this enemy into a function called isEnemyTargeting. And if it's true, then it sets that enemy to be red and see-through walls for you, so you can see them through any wall. And then same thing for all the rest of them. So if there are 3 of them that have seen you, out of all the people in the game, then it sets them all. But for the other ones, it returns false and doesn't do anything to them. Okay, I could see it. Output found walnut. Oh, or you could say like maybe a crafting material thing. Like if you say, let's see. Like when you open up the crafter, it checks to see how many of each item you have in your inventory. So it searches your inventory for an item and compares it to see if it has enough of whatever. So it's a function that takes any object, seems like. And let's see. It gets the object, it checks the type of recipe, it checks how many are needed, and returns whether it has enough or not. And then you could call that to say, hey, does your inventory have enough items? And if it does, then boom, good to go. But maybe that's better with like a custom counter. Okay. So we have a standard string view. We set found to be, so it's this array that starts here and ends here for an element that contains nut, and print the first one that is found. So in this case, we have apple, banana, walnut, lemon. It's going to print walnut. Cool. Because if you had one loop that checked the array and then two to match. Oh, because you need one to match each character to the character, so you're looping through this character. and you're checking to see if it makes this one, and then you have another loop maybe that loops to the other character. So like you're checking the first character to see if it matches the first of this. Well, oh, if it contains nut, that's the point. So you're saying you're looping through this string to find n, and then checking if the next one. So, and it doesn't break then. It finds the first n, and then it checks if the next one is u, and checks if the next one is t. And I don't know if we need to do fully 3, but it's at least 2. You're checking each word, and then checking for each one if it's nut. But then maybe if you're searching for nut, then maybe you are looping through nut. I don't know if you're looping through nut too. I don't agree. You just passed the index. Oh, maybe you are. I don't know. Okay. So we're looking for it. All right, cool. It's not super helpful, but it's cool. If you're gonna write it, blah, blah, blah. Okay. Standard count. How many occurrences there are of something, huh? How many elements contain the substring nut? Standard string view in position, in pause. The count, how many occurrences of something there are, okay. Need standard string view and array. String view. And then we'll say let's say there's a let's check how many enemies in the world are goblins. But goblin is anything that ends with LIN. Okay, so it takes standard string views, and there are 4 of them, sure. Because if I pass these in literally, it'll just do C style strings. Okay. Okay, say monsters, and we'll say goblin, hoglin, little Minecraft action. I'm gonna say roblin, and then jack, boblin. Okay. Oh, I'm sorry. I'll do 5. Okay. And we'll say bull is a goblin. Or is goblin. Return the bool. It takes a standard string view. Monster. Okay. And so we return okay, so we'll do a standard string view. It's called suffix len. And so we're checking one string view and checking if it has this. So what is this? Is this find? Interesting. Excuse me. Oh, oops. Okay. Haven't used found yet. Hmm. What do we call it? Count if or something? Standard count if. And so instead of finding the first one, it's going to count each one of them. And shouldn't this be an int? Oh, but not necessarily. In our case, no. Okay. Oh, because it's an int64 because it's a pointer. So it's the type of value is a pointer. So we could make it a standard null pointer, or I'm sorry, a pointer diff t, right? Technically, but it's assigned unsigned maybe? No? Oh, and now it cares. Okay, interesting. All right. Store how many number of goblins in a world. So we could say long, right? Maybe? What happens if we did that? Oh, even long? Well, we could say auto. Auto because... Well, no, because it's the number, right? Oh, but the point is it could be standard end. So it's either a pointer to end or it's just a big int. And what do we check? Oh. Is it count if? Does it still just return a pointer? I thought it was gonna find each one of them. I guess not. Oh, why? Oh, cause is it always just returning true? It seems like it is always returning true. I was hoping that it would return. Oh, the point is it's returning that standard string or standard string view null position, and somehow that's not zero. So return if it's not standard string view null position. Now we get 0. And now I'll and now we don't have to pass this because found is just the count. Boom. And now we can make this goblin. Hoglin. Boom. But if it was now a capital, now it'll go down to 2 because it's not lowercase. Fuck. Oh, it's the character. Can't convert. Okay, dang. Unlucky. Forgot that. We can't do that. We have to pass out a character if we're trying to convert from something to lowercase. Okay. Maybe we could count if, or we could just count. Yeah, that works. Okay, so we find it. If it's not equal to in position, returns that. The problem is that standard string view in position is not false when converted to a bool. It's 1. Why? Now we'll find out what is in position as a value. What type is it? It is a size T. Great. I can't. It's basically just a magic number. Wait, is it the maximum number of No? Oh, what the fuck? Limit. Wait, limits, yes. Oh, it's unsigned. Unsigned long. Told your ass. 18 quad, baby. Hundred, thousands, millions, billions, trillions, quadrillions, 18 quintillion. Oh my god. It is a quin. Oh, really? My nose felt stopped up. I blew my nose out a little bit. And booger. I'll be right back. I'm not wiping that on my glasses cleaner. Be right back. Good. Oh, my hair is so jacked. Oh. Okay, good. Wait, standard count searches? Really? Oh, it's just all. Oh, it's all occurrences of the element itself. So it's finding something or counting however many there are. And then there's count if, which is finding, excuse me, the count of how many things that satisfy a specific value or satisfy a condition. So, like, instead of searching for 986, 300, and 480, instead I can just search an array for values greater than 100 because that's what I'm looking for. I don't know what values I'm going to get. I just know that there are outliers in this specific conditional way, and I can search for them based on the condition that they are satisfying. Okay. Checking my phone because the people yesterday, Parker, whoever, said he was going to come in and do this wall shit. And I was procrastinating earlier because I figured they'd all show up at like middle of the day, but they did not. So probably about to knock on the door right now with my luck. How many elements contain a string nut? Okay, so we're saying, all right, we have an array of things, some of which contain nut, in our case, peanut. Cool. And then we search, so we do a count if, we search the array. So instead of, I wish it would just be passing the array, but whatever. We pass in the beginning and end of the array, and we pass in the function that we're going to be calling, that this thing is going to be calling. Now, to see if each element satisfies it. And then we're going to store the count. Or end. Oh, or maybe it's just 0 by default. It's probably more likely, actually. I didn't check it. I didn't verify. I should have. Please? What the fuck are we doing? Oh. Oh. Oh, the count is just 0. It's just that it's a big ass number. COUNTIF is a 64. Two nuts. Standard sort. I haven't. Oh shit. So what? It's like standard. It's standard swap basically. It's just it's bubble sort. It's just saying under what condition should it be sorted. So, like the ones that contain nuts should be after those that don't. Felt like my sock moved. Really? Oh, alright. I'll do the same thing as before then. Or what if we did this? Cool. Maybe. Hmm. Excuse me. Oh. Uh-oh, hold. Don't know where the issue is. What if we do this instead? Oh, really? That's where the issue is? I'm surprised. So this was fine. So sort is the issue, and we are sorting based on. Oh, hold. Oh, it takes two elements. It takes one and then the next. I think that's the point. So monster one, monster two. So we return whether, or we return true if, hold, if the left monster is a goblin. We want goblins to be on the right, so we're going to return if monster one is a goblin. Return, we only want to swap if monster one is a goblin and monster two is not. If they're both, we don't swap. I don't think that'll do the full thing. I think we'd have to loop that, right? Maybe not. Maybe it already has the loop built in though, and has the check to make sure that hey, they've all been moved over to the side because this is bubble sort basically. Return weather. So if monster one, so we need to do standard find. We're gonna search monster one for. Wait, hold on. What? Hold. We're gonna do monster one find. What are we searching? Oh, we could do either way. We could do find goblin suffix. Monster one needs to be, and monster two. Oh, these need to be. Hold on. And hold. Because the find. So we need to return that. That the left monster is not standard string view null position, and the right one is. In monster 2, to find goblin suffix is standard string view null position. Bop. Because it wasn't happy with the function call, because the function was not comparing two elements, it was only taking one. So it was calling a function that only takes one element with two elements. Oh good. Oh wait, we're not printing yet. Excuse me. Hello? Oh! Wait. Okay, it didn't do anything. Oh, awesome. So. Interesting thing here. Well, actually, I think we need a condition here. Or no, isn't this fine? Instead of saying if this, we say, hey, if the left guy is a goblin, Lynn is found in the name, and the right guy is not found, that's when we swap. And it's really like, is left goblin and right not. Let's check here. Say print 1, 2, 3, 4. Done. Alright, hold. So we have monster 1 and monster 2 that have been passed. And we check. And is goblin will return false. Makes sense? Now we're passing in hold. Fuck. Monster 1 is Jack. Bro, what? Why is it taking in those two? Why is it doing Jack and Goblin? And then it compares Jack and Hoglin, and then Death and Goblin, and then Death and Jack? Bro, what? So we're passing in Monster 1 and Monster 2 as Goblin and Hoglin. Why is Hoglin going in first? That makes no sense to me. Oh, deja vu. My God. Okay. Okay, what the fuck is going on here? How is this shitty function working, huh? Greater return with a left is greater than right. So what if we said Monster 1 is greater than Monster and now G, H, I, J. So it's sorting greatest to least. In ascending order. Are you tripping, bro? So if we said less than, then Jack goes at the end. Excuse me. Order A before B if A is greater. Bro. This is... So we're saying don't swap if it's true then. We're saying G and H. We're saying which ends up first? Goblin and Hoglin. So Goblin and Hoglin stay. Because we want G to be before H. G is before H. But if we do greater than, then H is before G. So don't we want the opposite of this then? Or I can just do this. If this is this, and this is this. What the fuck? So the problem is it's... So we want to swap. So the point is if it's true, then it's sorted. So we want this to return false when the goblin on the left is not found and the goblin on the right is found. Are you sure? It's Goblin and Hoglin, and then Goblin gets bubbled down. Excuse me. Excuse me, because if we pass in Goblin and Jack, Goblin, this is going to be false because Goblin does contain it. So Goblin find is not going to be this. So this is going to return false because it's going to short circuit, meaning that, well, it doesn't matter. I don't even need to say it. Yeah, fuck it. Meaning that the left condition in the and it has already failed. So it doesn't matter if the right is true. The whole thing is evaluated to false because it requires both to be true. So it returns false. And because it returns false, it will swap and bubble Goblin down. False. And so if something is greater than if it's greater than, so if A, hold on, order A before B if A is greater than B. So if A is greater than B, it should not swap. So we're putting in what's true to not swap. So if this is true, it shouldn't swap. So if the left guy is not a goblin and the right guy is a goblin, then it should not swap. And that's what we get. We end up with goblins all on the right. Okay, this kind of makes sense. I think the implementation is retarded, but it's okay. Okay. A greater function needs two arguments, but we're not passing it any. Where do they come from? It's a function pointer, meaning that it's calling the function pointer with the elements that it chooses in its own logic, meaning that we call it, and it finds the current element, finds the next element, and then passes them to the function. Can I store the function? Fuck. What was it? Oh. What would you say? Auto thing, test to be thing. It is a pointer to the function. What if I did address of thing? And then I did the same thing, or rather, what if I just did test? Oh, I guess I can't. Wait, what? Why not? Oh. If I just did thing, and then also, or and then inline, and then also, oops, inline character, sorry. And then address of thing. Same thing. Yes. Interesting. So it's an address to the function because things can apparently use the function. It's not just a thing that's substituted. It's... Huh. It's a function pointer, not a call. Yeah, I do not get one, buddy. Because it's not defined which sorting algorithm. Hold on. That part doesn't matter. Sorting and descending is so common. Standard greater, meaning just greater than something. Oh, just sorting and descending order, meaning descending order of grade. Oh, well, I guess if you're saying descending or ascending, you're sorting. You're talking about numbers, right? Integer comparisons. Instead of calling R greater, we could do standard sort, begin, end, and then greater. What? Why do we have to do this initialization logic? Needs it because it's not a callable function? What the fuck? It's a type? What does that mean? Wow, that's crazy. I have two separate people singing in my ears. This is insanely good. The curly braces instantiate an anonymous object of that type. Sorting an array with selection sort. So we say, okay, we have a C-style array, and then we are passing it to sort, and then we're printing it. So what is sort doing? Sort is taking pointers to integers, which are begin and end. We just have to hope that we're not dereferencing it, I guess, right? We say, well, begin is, okay, not equal to, because some iterators are not comparable with less than or greater than, or they don't evaluate properly. So if we're comparing to end minus one, hold on, while we're at end minus one, oh yeah, so we're not sorting. Oh, because we're not comparing it to the next element, because there is no next element, so that's fine. That's for bubble sort, regular sort, any sort. Okay. Smallest element, and then we loop through the whole guy, and we save. So we save the smallest element, and then we compare the next one to see is it smaller than the smallest element, and if it is, we set it to be, well, oh, if it is, we set smallest element to be whatever that element is, yes. And then we swap, hold, then we swap whichever one that is with the smallest. So we say, oh, okay. Swap, and then, oh, this one's smaller, swap, smaller, swap. And then we go through the whole time over and over. Well, I guess no. We make the bottom be the smallest, and then the next one has to be the smallest from then on, and then the next one has to be the smallest from then on, because this one is only sorting from standard next is the next one, I guess. It seems like this is a static or start element. Oh, this just increments the pointer, right? For this guy, and then instead of having to increment them in here to start at the next one. So we're not searching the entire thing every time. Standard next is a pointer to the next element. Gotcha. Okay, so every time this executes, every time the whole loop goes, let's see, so it's for the entire array. Search the entire array for the smallest and swap, and then we go to the next one. Okay. Oh, what the fuck is that? Standard function in bool is a function that returns whether the two are the same. Or it's a function that returns a bool. Interesting. Bool takes 2 ints. Oh, okay. And so I could create a function that takes a standard function to call. Oh, fuck. Really? Instead of, oh, if this guy's less than this guy, we just do if compare this guy. Well, okay, this is just logically worse, objectively. If this is less than this, instead of if, and then I have to go into compare to see how it's being compared. But we could have it be a template one so that we can sort it in different ways, maybe, but like we could pass it this function in this way and this function in another way, maybe. Because we could have different functions and we choose which function we're going to pass to it. Or hold. Oh, meaning sort here calls that function. Or, well, it's just using it. Okay. Well, the point is, if we were passing it the function, what would it be doing? So we pass it the function, and it compares and returns a boolean, and it takes... Okay. Why are we... Oh. Oh, because instead of doing standard sort... Oh, okay. Are you sure? I don't think standard sort... We're not using the namespace, bro. Sort shouldn't do anything. But okay, or it shouldn't conflict. But okay, so if we say global namespace sort, pass in the start, pass in the end, and we're going to pass in the function to call to determine... And so in that case, there's a function that is greater, that is returning it. Like this. I'll do that in a minute.